Thank you, thank you. We're very happy to be here. We will be talking about TouchDesigner for creative prototyping and innovation. Even before introducing ourselves, we are just going to dive into the topic. We have a lot to show. Apologies for the pace. We got super excited because it's the first time we understand that TouchDesigner is mentioned in this conference. So we try to cover a lot of ground. We're going to rush a bit. We're going to, not go so deep into topics, but we will try to give you enough information to get you motivated to check it out, hopefully. This is the description of TouchDesigner that you can find on the website. I suggest you to check it out. However, the one line I want you to take from this is this one. So TouchDesigner is the platform that can do it all. It really is the case, especially in our field. Our field is quite different than the vast majority of yours because it's not really about gaming or rendering. It's all about real-time graphics. So a little bit of the context of TouchDesigner. The origin of the software is from the Houdini 4.1 code base. Greg Hermanovich, who is a co-founder of Side Effects, in the year 2000 founded Derivative. And Derivative started working with this code base to develop TouchDesigner as a solution for a real-time application. So whoever is using Houdini will be very familiar with node-based environment and the logic of Side Effects, of course. TouchDesigner is very similar, so you will feel at home there. We have nodes, we have the similar structure of dealing with data, chops, subs, this kind of stuff. And like I said, it's built for real-time procedural tool for artists and researchers. But I will let Greg Hermanovich, the founder of the company, tell you exactly what it is about.
When you start to design TouchDesigner, and after all these years, was already in your mind all the different applications that you can realize with your software?
Yeah, I really think that TouchDesigner is, I wanted it to be a general tool that didn't presuppose how people would use it, because I wanted it to be used for people in music, in art, in conventional show control and advertising, and also by not just by artists but also by researchers, people who wanted to visualize data, and also I wanted to kind of span age groups as well, from younger kids to older kids. So some of the earlier projects involve kids using TouchDesigner with elders and so on, and also knowing the art of the world, I wanted it to be kind of generally, culturally neutral kind of thing. So, we just want to support the craftsmen who are making art digitally. So that means touch has to be kind of very stripped down to the very simple elements.
All right, so this gives you already a little bit of context of the scope of the software, and is indeed beyond gaming. So the kind of applications that one will choose to build with Touch is quite diverse. Here we have some examples of what you could build. For example, there are live shows, audiovisual shows. One of the most famous ones from here, perhaps, is Amontov's Isam, that was TouchDesigner. You can build tools like GeoPix by Environmental Design. You can have scientific applications like the Gran Tecan Digital Twin, it's a telescope in Gran Canaria Islands by WFX Lab. Or you could even use it in a film set like Ridley Scott's Alien Covenant. And other examples that maybe you're familiar with, like Carsten Nicolai's or Scalar and so on. Here we listed some of the things that we think TouchDesigner is strong at. From here, the highlights would be rapid prototyping and the exceptional interconnectivity. You can truly hook anything to anything, which is a major selling point for the platform. And of course, the amazing community and support that it has. It really is one of the most inclusive and nice communities I've been part of. And for that, I want to thank Greg and Isabel for keeping it like that. We made an unreadable list of features that you could maybe use. But I wanted to focus on this. Maybe these are the kind, we try to choose projects to showcase today that sort of combine all these things to create the outputs. So yeah, it's quite a mixture of things. Now you may be wondering, yeah, nice, but who are these people? So now it's time to introduce ourselves. I pass it to my friend Nikzad.
Hello everyone. So my name is Nikzad. I'm an interdisciplinary artist. And I'm a founder of Internal Studio. So for the next 5 minutes, I will showcase a couple of my projects to give you a glimpse of how I use TouchDesigner and my approach when it comes to design. And definitely I might skip and forget some details, but after this brief showcase, I will present a small example in action. I will do my best to highlight some of the useful features in TouchDesigner. So I'm going to start with Telepersons. It's an interactive audiovisual immersive experience that I designed for RGBXYZ Expo in Amsterdam. The main idea of this installation was to blend a synthetic world generated by codes with our physical surroundings. So unlike VR, where you're fully immersed in a digital environment, these installations keep you present in the physical world while you're guiding through the 9 different digital states. So you could physically interact with abstract elements using multiple Kinects, tracking your movements and basically reshaping your journey through 10 minutes experience. The second project is Gentry, is an audiovisual installation with 36 screens set up. And now let's go over the main challenges that I had to tackle with this installation. So basically I had to coordinate real-time content across 36 screens. I had to find solution to distribute texture and synchronize frame across screens. I had to design dynamic mapping tool to prevent overlapping, and also I had to composite real-time content with pre-rendered videos. So first I had to figure out how to wrap a huge and unusual texture across 36 physical screens. So I don't remember the exact resolution, but I do remember when I first calculated the pixels needed for this installation, I was laughing and crying at the same time. So to handle this, I designed a custom shared memory system across 3 GPUs. And because the certain decoding required CPU processing, I had to use 3 workstations for frame synchronization. Right. I designed this AV, audiovisual installation, and showcased the Video Forums Festival in France. And the physical installation design was inspired by the chapel's architectural space, and the visual and sound were generative. So the main concept behind this project stemmed from my fascination with artificial life, aka A-Life, and some of my early paintings from 2004 to 2010. And it was a revised reversion of my earliest project called Refactor. So, and also I'm going to showcase this project. It's a good example to showcase that rapid prototyping is not just for small funnels or experimental project. This project was an interactive visual and light show for the Saturday night show of Amsterdam Open Air 2003. So a stage designed by TouchDesigner company featured 3 elegant pillars set in the middle of woods. Very interesting setup. And my task was to create an interactive design that could respond to the audio lines from our musicians. So in my design, I considered each pillar as a container for a physics-based particle system. Then I introduced various forces, colors, and materials as parameters into the system. And also for the audio interaction, I designed an audio analyzer to filter and separate the inputs into a full audio spectrum. And then different parts of the spectrum were mapped to different set of parameters, creating a generative particle system that interacted with the sound stage. So the other interesting challenge was mapping out the visual output onto the pillars and finding the best virtual camera angle from my rendering pipeline to physically simulate 3D depth within the structure. So the front side was physical facade, while the back side was virtual. It was very important to align them accurately for the illusion to work. At the end, we collaborated to create a 90-minute show in just 2 weeks. I mean, there was no any other way. With the high stakes and expenses involved in such massive setup, we had to work as quickly and accurately as possible to avoid any mistakes during the live performance. So I'm gonna skip the maze, and I'm gonna leave it to Darien to explain. And so I'm gonna dive into one of my patches in action, but before that, let me give you a backstory. So, back in October, I got a call asking if I would be interested in designing a light set for TEDx Amsterdam. Naturally, I was delighted, so I quickly checked out some TED Talks videos, you know, TEDx being TEDx, pinch dark venues, one spotlight on the speaker. Super informative and inspiring, of course, but then I thought, what can I do as a light designer? Just one spotlight. But then I found out there was a catch. So they booked the wonderful grote zaal at the Muziekgebouw, so this building. This is a massive space, 2,000 square meters of walls, fully decked out with 200 LED walls panels. So when I visited the venue, it was like staring at the vast empty canvas with infinite possibility. So I think, yeah, let's go wild with it. And anyway, long story short, together with the amazing team behind the TEDx Amsterdam, we created this. One spotlight. Alrighty, so I'm gonna dive into the patch, and from this moment, please expect crashes, a bunch of errors, because this is not gonna be PowerPoint anymore. Boom. So. Yes. Right. So, when you open TouchDesigner, basically this is a first level, and then we usually make our own hierarchy and structure, and we're working with TouchDesigner to avoid any frame drops. And then, before diving into the boring part of connecting nodes together, because this patch already made a custom-built UI, and also, important thing is this patch is also connected to Ableton, if you know Ableton. So it is audio, visual, and light show. So I'm gonna start the show, and then from TouchDesigner, it's gonna send one signal through OSC to the Ableton, and then from Ableton, of course, we do have this channel packed with MIDI signals, and each MIDI basically cues or triggers one of my lighting presets. So,
when you're not observing something.
So this is the overview of the space. Of course, don't judge me. My rendering is not basically, it's just a previs, and also it's a controller. It's a controller for all the lights and everything. So we do have 2,800 panels of light.
It's like a video game.
And now I can basically control everything through this previs, and
it hasn't even been rendered yet.
Let me dive into the patch itself. Okay, so of course for the lighting design,
that's when it comes.
So in most venues there is a lighting desk that you can design. Of course, you can access to each different fixtures one by one, and then design, assign one color to one fixtures, and then group them together, do a bunch of things. But when it comes to 200 fixtures, and when you want to make a real-time lighting setup that is connected to sound, and then of course for the first part we had the performative action. We had 2 dancers, by the way. This is me just mimicking one of our dancers. Again, don't judge my dancing skills. And when it comes to such a complex setup, having even a huge and complex lighting desk like a Grand MA is not going to be enough at all. So my approach for this project was to use generative textures and then basically convert those generative textures into pixels. Pixels into data, into channels, and then send it out through our lighting setup, through DMX protocols. So if I can show you, maybe I can setup run. So from Ableton, it keeps triggering my lighting presets. And these are basically, each container comes with a preset that I quickly hooked up together. So mostly just generative noise. And then eventually, when I made a texture, basically this is a texture for all these lights, which is converted into channels and then sent out to the lighting interface or DMX interface. So that was the lighting setup for this project. And do you want to dive into? Yeah. So let me pause the setup a moment and switch. Alrighty.
All right. And I will keep going on. I think I need to extend these guys. Yeah. And I am there.
You are installing technology. Yeah.
Yeah. Okay.
And then, there you go.
Okay, so yeah, I still need to introduce myself. I'm Darien, Brito. I'm a creative coder and audiovisual artist. I work as a freelance. My work is usually, or was usually, audiovisual shows like big screens and multi-channel setups. This is, for example, a performance I did with an artist from the UK, Jonathan Knox. We made an AV performance in a full dome environment. You can see the scale of the space. It was a really great experience. And this was the first time I started to dive seriously into TouchDesigner. Then this is a project where I did, it's one of my personal pieces. It's a live audiovisual performance where the sound and the computer graphics are generated live. So this is a common thread in TouchDesigner that you don't render anything. You usually just generate everything live. So there's no videos. It's all on the spot, which has its risk, but it's quite fun also. And yeah, these are the things that I'm usually quite busy with as well, generative art in general. I do a lot of design for artists or my own projects, simulations, physics simulations, and just art pieces. So this is something I do as well a lot. I will not dive into any of those personal projects because I think they are not really so interesting for you, since I think you more or less deal with similar topics in your own work. You're all designers, you're all doing things with games, you're all doing content. So we were trying to think what could be something interesting for the conference that gives you a little bit of a glimpse on our world. So this is one of these projects. It's called Amaze. It's an immersive audiovisual experience space located in Amsterdam. We developed this in 2019 as a result of the pandemic because we couldn't play any shows anymore. And then if you are Dutch, probably you know who IDT are. They are one of the biggest producers of events in Holland for electronic dance music. And they commissioned us this space, well, as YFX Lab, is a studio in Amsterdam. And yeah, we decided to go for it. The task was to build basically 8 rooms, and each one of these rooms had to have a topic. This carried a lot of challenges. One of them is that it needs a reliable show control system to run everything live. The second one is that it has to be mostly real-time content. There was only 1 or 2 rooms that didn't have any, that was, let's say, pre-recorded. It had to have many different technologies involved, lights, lasers, projections, and so on. Interactive elements, so that means sensors in space, which creates a lot of headaches, things you can do with lights. Some sensors are infrared, some sensors cannot handle certain kelvins, and so on. And strict timing. This because when you do a live show, you will need to have people walking in a certain way, and you need to be careful of how they walk at what times, that they don't collide, and yeah, this is a nightmare to manage. And finally, that is a permanent installation. You can actually still visit it, still running in Amsterdam, if you were curious. But this means that the hardware and the software had to be robust and solid, so it could be running forever, basically. I will give you a very brief view of how this space looks like in practice on real life. Sorry, I have to skip because we have still some stuff to talk about. A very brief view of what the challenge here was and how the structure of the space is. You have a reception where you go and take some drinks, you meet each other, and it's nice. And then you have a master clock scheduler. Everything, by the way, all the system is TouchDesigner based. So the master clock was a TouchDesigner instance just basically sending messages through a protocol called MQTT. It's an IoT protocol. Maybe you're familiar with it. And this sends messages to each room to know, first of all, if they're available, if they're ready, if they're in a good state. And then it also sends timing control to queue the people that are going to go in. They're working in groups. So you go linearly from the beginning to the main hall. On the right, I list some of the things we used doing all the rooms. And like I mentioned, this was developed by YFX Lab together with a big group of people. We among them, and here are the names of other developers involved. So another project I would like to mention is this one. It's a project I did for Michel van der Aa. He's a Dutch composer, and it's a multimedia opera. The multimedia opera means that you have an orchestra, the typical stuff, orchestra, singers, director, but you also have multimedia elements, of course. So visuals, we had in this case multi-channel audio, we had also a motion tracking system, and we had, of course, this particle-based system that is using that tracking information to render live. So I'm going to give you also a very brief view of the trailer for this, or the teaser.
It's uploading. Your physical brain will be terminated.
I wish I could push you. My heart is shaking. I hope to do the same. I wish I could better you. Give up your body. Take one.
Yeah, so as you see, there's moving screens. Some of them are translucent. I mean, it was a very complicated setup. But I want to speak about one particular challenge that I think may be interesting for you. It's the live motion capture or scanning of the character on stage. So the challenge was that we had to manage multiple Kinect assured devices. I don't know if you know what those are. These are infrared cameras that give you a point cloud body. So we had to merge multiple point clouds into one to have the illusion that is one solid object. And the challenge was that it had to be an automatic solution, because when you're touring with an opera, every stage is different. So the elevation changes, things move around, the floor, moves too. So your calibration is never going to be the same as where you started with. We had to have a solution that will work with one click of a button. For this, I took the approach first with OpenCV. It's a library for Python. And you had to use these funny Charuco-based boards to calibrate the location of the cameras. But that didn't work for our purpose because it was not accurate or fast enough. And then I went for an Open3D approach, which uses global registration. If you deal with point clouds, maybe you know what global registration is. In short, it's just a way to combine the point clouds based on their proximity and their similarity. And this worked pretty well. That's me testing the thing I was building. So how this works is you had unmerged cameras. You can imagine already the problem with having 3 different cameras from different angles, because if you are going to simulate one object, you need all of them to have the same reference point and basically share the same world position. For that, we needed to merge them. So what I did is to point register them in pairs, programming this tool I was showing before. And then at the end result, you see the merge mesh, let's call it, which is not really a mesh, but point clouds of the cameras. Essentially, what the system does is outputs a 4x4 transform matrix per camera that you can later plug in your software and simply multiply it for the vertex, to the vertices of your geometry, and automatically it's all in place. Yeah, if you're curious, I made this tool open source, and the good thing about it is that this challenge I had with this project led me to find a solution that later on became quite handy for the community as well. So that's where the innovation part of this thing came into play, and which I wanted to show you. I will skip the network of this project. I wanted to show you how it works, but there's not much time left. So I will rather focus on this last project, and here I will show you also the network. So this is a project I did also with YFX Lab for the BBC Earth experience. BBC wanted a space that is an interactive space where you will have content that is very close to reality. They wanted it to be as close as possible to that. But as you can imagine, when you have real-time content, doing that is very difficult. We don't have any of the possibilities you have when you have offline rendering, which is having all lights and really high definition polys and all that stuff. We have to make concessions and find hacks and find solutions to make it work in real time. So this is how more or less it works, or it looks like. I'm going to speak particularly about this one, this reef. And as you see, or maybe you cannot see from this video, but it's all also interactive. So there's a bunch of interactive elements on the space that need to react to people as they walk by. Okay. Challenges on this one. Like I said, interactive space, it's also a permanent installation, so reliability, the robustness of the system was very important. This one is a mix of real-time content with pre-rendered videos, which BBC wanted. Then we had to simulate the fish behavior, so there had to be some algorithm to simulate flocking. And we needed to have also generative audio elements. To give you a brief idea of how I structured this part, there was the background layer, which is pre-rendered, and is the static part that everything is going to be layered on top of. There was the video layer. It was pre-rendered with alpha, and it was packed later in the program in a 3D texture and then placed as billboards in the scene. I think this is a common thing that we all know what it is. And then the particles layer, which was the real-time content component that was done in a compute shader, which was later on mapped to a rigged fish in a vertex shader. So the final element was to put them all together in composition and then rendering out. So what about the interactivity? So we had the Kinects, and what we did for this project was taking a little bit of a different approach. With Kinect, you can get a skeleton data. However, for us, that was not good enough. And we use JFA is the jump flooding algorithm, which you may know, to get an SDF, a sign distance function, of the body of people, which allow us to have a much more accurate and very detailed contour of people when they go into space. So that was the element that went to the particles for positions. And then there was an optical flow element, which is a technique that allows you to basically deduce the velocity of the vectors of movement of people with pixel information. And we also had a timers, pixel shader, made in a pixel shader to drive the videos. All right, this was developed with YFX Lab. And now I will be brave enough to jump to my machine and show you the network as fast as I can, because time is really short. Okay, need to move it there. Okay, so far so good. This is your mouse. Yeah, it's mirrored already, so that's great. Okay, let me start very quickly with the sound, the generative sound element. How many of you are familiar with sound synthesis by raising hands? Okay, there's a few of you. So I use a programming language called Super Collider to do the sound design. It's basically this. The important part to take away from this is that everything, all the control for the sound triggering is done via OSC. And I program all the sound synthesis here. But everything comes as the simple messages that we can interpret, and basically you have sound. The patch itself launches a program, which is the sound engine, the server for the sound, and I will hide that part. This is how it looks like. This is the riff. The elements I was mentioning before, on the back part, all this is the background is static. These ones are the videos that are the billboards that are played. And these ones are the particle systems that are real time. You can see little creatures here that will move based on how people interact in the space. And they're basically triggered by these timers that I mentioned. Okay, now let me do a quick show, if I can. Of course, you were supposed to have a person in the space. So the person, when he moves, the fish react to the person. I will make it a little bit nicer maybe here. Yeah, so you don't see the person. And now I will show you very briefly how it is structured in TouchDesigner so you have an idea of how you will go about programming something like that. Essentially, I will go through first the video, which is the easier to understand, I think. So the videos are basically just, indeed, sprites that are in here. These triggers hold the animations. There's two types of billboards that I'm using. First, just bubbles. These bubbles are triggered by its own compute shader here. And there are also the billboards of the videos themselves. Here. Oh no, this is also bubbles, sorry. Trigger system. Here we see the way on which the data is interpreted and queued to the trigger system, which I simulated here. And when that gets triggered, you will see that something moves in the space. So let me briefly do that. I put the volume down. So I'm going to trigger some turtle, and you will see that the turtle starts to appear on the right side. And I will trigger some squid, and it will come at some point, the squid going up there. So these things, they get triggered based on how much time people spend on the space. And they are managed by this timing system that I was telling you about. The timer system is here. It's just one pixel shader. I'm not sure if this is interesting for you, but I'll quickly do it. But we did it in a pixel shader because we didn't know how many videos we will end up having, and it needed to be fast as hell, very optimized. That's why we didn't use a CPU version of a clock. We used a GPU version of a clock, and this is basically the logic that controls the timings. And these outputs, of course, pixels that we later interpret as data for time. And finally, let me show you the particle system of the fish. Here we have different textures that go as inputs for data to the fish. This is a compute shader that is making the calculations. And like I mentioned, there were some things we had to take care of. There's a bit of a noise involved. There's a flocking. There's some attractors. This is the flocking system, separation, alignment, cohesion, that controls how the fish move on space. And there's, of course, an element of interactivity that is basically a bunch of vectors that we kind of faked it because it was the easiest way to do it. A lot of the times when you do real-time content, you want to fake things instead of doing it super accurately because of computational resources, and simply because sometimes it just looks better. A lot of you also mentioned that in your talks, that sometimes doing things by hand is more effective than trying to simulate everything with code. And yeah, it's true also in our work. All right. And now finally, oh, damn it. I'm still learning PowerPoint, by the way. I'm sorry. Oh, this one, yeah. Finally, you want to say this? Okay, finally, we wanted to mention that we're currently doing a series of master classes with Innovation Lab Theater in Utrecht. And the master classes are directed at different creatives of disciplines, as varied as possible, sound designers, stage designers, people like you, or people who have no idea about computers. And we're trying to ease them into using TouchDesigners for their projects, which, as you see, may be an additional toolkit for you, since you have all the knowledge for render things and games and so on. I think for you it will be easy to also dive into the real-time arena if you're interested. Finally, we would like to thank you for listening to us. Thank you for inviting us. These are our websites. I think these are Instagram QR codes if you want to follow us. And we would really like to thank a couple special people. So Tim and Roy Herritzen, who are from YFX Lab. Roy suggested us to you to participate. Thank you, Roy. And Isabel and Greg, who are the, let's say, the heads of TouchDesigner. They made a great software, and we're happy to use it and share it with you. Thank you.
Thank you, guys.
I need some water, man. Jesus.
Hello, this was super cool. Nice work, guys. Do you know if TouchDesigner has integration with any kind of game engine? I imagine that like VR could benefit greatly from it.
Yeah, there is a plugin for TouchDesigner into Unreal Engine. I'm not sure about the Unity part, but
No, there's no Unity plugin.
yeah.
But Unreal, yes.
Yes.
And there's a thing called TD Engine, TouchDesigner Engine, which is a way to run whatever you build in Touch in other software. I haven't tested it thoroughly myself, but it's there, yeah.
Any other questions?
Let's say someone I know has a couple of projectors and he just placed them in a room. Is it kind of accessible to just start messing around with it?
Absolutely, just plug and play, put some notes together, put it out, you're happy.
Awesome.
Okay, I'm looking at the time. I think it's time for the next talk. Thank you, guys.
Thank you.
Thank you.